The names on the vendor list can be complete, and a valid certificate can still move money, ship code, or change identity on the same day. The folder that holds the list looks finished. The rail does not read that folder. The rail reads the certificate, and the certificate was already handed out. The breach used a valid certificate because the vendor list is not the attack surface. The attack surface is the trust you already handed out. Name the grants that are already in someone else's hands. Name the certificates, the tokens, the API keys, the signing keys, and the delegated authority. Those names are what a rail, a build, or an identity broker will actually read. Third-party risk management, TPRM, does not erase imported risk. A company that uses other companies will import some of their failures. The work is to keep the imported failure inside the board's appetite, which means naming the grants, not only naming the firms. Appetite is the amount of damage the board will still accept after a partner is wrong. A supply chain attack surface is the set of paths an attacker can use because you already trust someone else to act for you. You do not own those paths the way you own a laptop on your desk. You inherit them when you accept a certificate, a token, a build, or a support role. Inherited means the door was opened by a decision you made, not by a hole you forgot to patch. The inventory of vendors can be complete, and the surface can still be open, because the inventory counts companies and the surface counts grants. A list is one column of names. A grant is a privilege already in someone else's hands. Who can speak, on which rail, with which certificate, into which account, on behalf of whom. Names can be finished. Grants can still move money. Those two counts sit on one table because they answer different questions. A list asks which firms you enrolled. A surface asks which grants those firms can already exercise. The list is finished when the name is on the page. The surface is finished when the certificate, the token, the signing key, and the support role can be named, shrunk, and taken back. Ownership and inheritance are different questions. Ownership asks which legal entity holds the asset. Inheritance asks which outside actor can already move money, change code, or assert identity in your name. The written contract can name the vendor. The attack surface is the privilege that vendor can already exercise. Legal title does not travel with a debit. The customer still calls the institution whose name is on the account, not the technology provider that held the certificate. TPRM only constrains what it can name, and the things that must be named are the trust objects already in other people's hands. A trust object is a credential, a certificate, a token, a key, or a role that lets an outside system act as if it were you. Attackers do not need to break a control if they can operate inside a trust object that the control already accepts. Breaking a control leaves a scar. Using a grant leaves a session. The interesting question is not whether the vendor is on a list. The interesting question is which objects you already issued, what those objects are allowed to do, and how fast the grant can be taken back. A certificate is the cleanest picture of that fact. An institutional certificate from PKI, which is public key infrastructure, is a signed identity the rail treats as the institution itself. If the private key that matches that certificate is taken, the next message is still valid under the protocol. The control sees a permitted speaker. The business sees money leave, code ship, or identity change. Validity is a protocol fact, not a comfort fact. A certificate can be unexpired, unrevoked, and correctly chained, and still be in the wrong hands. The rail, the build, and the identity broker were trained to say yes to that speaker. PKI exists, so a relying party can accept a speaker without calling that speaker on the phone. That design is correct. It becomes an attack path when the private key or the enrollment process is taken, because every downstream control was trained to accept the grant. Money moves because the payment rail already trusts the certificate. Code ships because the installer already trusts the signature. Identity changes because the broker already trusts the role. Certificates are one family. API tokens and OAuth tokens are another. An application programming interface is a machine-to-machine doorway. A token is the machine password that doorway accepts. OAuth is an open authorization protocol that issues a token instead of sharing the account password. Rotating a human password does not close that path if the token remains valid. A signing key marks an update, a package, or a payment message as genuine. Customers install what the key endorses. Banks settle what the key endorses. A support role that can reset a lockout is the same family in human form. Delegated authority is the name for the whole set. Delegated authority means you asked another party to act in your name, and the system treats that act as yours. You can delegate the act. You cannot delegate the impact. The organization still owns the impact because the account that moved, the code that shipped, and the identity that changed were yours. Attackers study those objects because operating inside the rules is cheaper than breaking the rules. A broken control leaves a scar a detector can name. A session that already has a grant leaves a Tuesday the detector was trained to bless. The detector that only watches for deny events will bless the allow. The list asked whether the speaker was enrolled. The fraud used the enrollment. The mechanism is easier to hold when a public rail already treated a valid certificate as the institution speaking. Pix is Brazil's instant payment system, and settlement runs through SPB, the Brazilian payment system. A payment service technology provider holds institutional certificates, so it can send orders on behalf of client institutions. On June 30th, 2025, C&M Software, a provider authorized by the Central Bank of Brazil, was compromised. Public reporting described attackers using valid institutional certificates and the matching private keys to issue protocol-correct Pix orders. The orders were not malformed. The speaker was a speaker the rail already accepted. The vendor list at a client institution could have been tidy. The attack surface was the certificate and the delegated right to speak. Treat public loss figures as estimates, not as a courtroom total. The teaching point does not depend on the last digit. The teaching point is that a protocol-correct order moved reserve money at rail speed because the rail was doing the job it was built to do. The reserve account that moved was the institution's reserve account. A program that inventories names and skips grants will keep passing reviews while an open grant stays on the rail. Name the certificate, the token, the signing key, and the support role. Name what each object is allowed to do. Name how fast the grant can be taken back. The column of companies is only the place those grants land. Regulators, customers, and correspondents do not split the blame between the brand and the licensed provider. Treat the certificate as an extension of your own identity store. A weakness you would not accept on an internal signing key should not be acceptable on a vendor certificate that can already speak for you. A tidy vendor list can sit beside a grant the rail already accepts. The supply chain attack surface is inherited trust, not a column of names. A trust object is a credential, a certificate, a token, a key, or a role that acts as you. Validity is a protocol fact. Delegated authority lets another party act in your name. On the C&M software pipe, a protocol-correct Pix order still moved reserve money because the rail already accepted the speaker. Thank you.